Okay. So, hello students. So, last video session we had seen how we can insert at a specific node after a specific node and how we can insert at the end. Right. So, today's in this video session, let us see how we can delete at the beginning. That means we want to delete the first node of the doubly linked list. So, what we can do or how it can be done. Now, if head first thing that we have to check before you delete is whether the list is empty or not. So if the list is empty, we cannot delete anything, obviously. So how do we check that? So we check if head is equal to null, then the list is empty, so deletion is not possible. Else is what? Else is the list is containing some elements. Okay, so you want to delete the first element because it is deleted at the beginning. Okay, let me take an example. So let me say this is the So this is the double linked list that I have. So as we know, previous of first node will be null. Next of last node is also going to be null. Okay. Now, what we are doing, let us say first I will, what we have to delete, delete at the beginning means I want to delete this 18. 18 should go. If 18 goes, what are the changes that you have to make? First let us see that. So this head should not be pointing to head 18 anymore. It should point to 20. Okay, correct? That is the first change. Next what? This previous node of 20. It has to be null because this has to be null because there is no node in the beginning. 20 becomes the first node. So these are the changes that we have to make. So let us see what we can do. So I have displayed head of data. That means I am trying to delete this. I just want to display what I am deleting. 18 will get deleted. S is equal to head. I am taking a pointer S and I am initializing S to head. So this is currently head is 18 only. So S is initialized to that. Head is equal to head of next. Which is head of next? Head of next is 20. So head will now be pointing to head of next. So head should not, this is gone now. So head should now be pointing to 20. How do I access 20? 20 is nothing but head of next. So it will point to head of next. Next. I told you this link, this node will now become the first node. So previous of this node should be what? Null. Is it wrong? So that is why now new head is what? Head is 20. So head of previous is equal to null. So head of previous will become null. This can't point here anymore. Are you getting? So these are delete yes. So we already, I told you when starting with linked list, I told there are two operators. New for allocating memory. Delete is for deallocating the memory that we have assigned. So we are trying to deallocate that by saying delete S. So this node, whatever memory is allocated for that will be given back to the operating system. So head is equal to head of next. That means this will become the new head now. This is gone. Then head is head of previous. Now this is a new node. Previous of this should be what? It should be none because this node doesn't exist. So that is what we have done. Okay, so this is how, it's very simple. This is how we try to delete at the beginning. Now you can also check for one more condition where if this is the only element, then what to do? Then you have to initialize head is equal to null. That you have to do. That condition I have not taken here. Probably you can try it in the lab when you are doing. Alright. So delete at the beginning. First we are checking for empty, and then if the list is not empty, we are trying to delete at the beginning. So next let us see how we can delete at the end. So we have declared double list class as double LL. So delete end was the function. Now we are trying to delete a node at the end. Okay. Again, what I said, you have to check if the list is going to be empty. If the list, how do you check that? Head is equal to null. So if head is equal to null, then list is empty, deletion is not possible. If the head is not null, so I mean, if the list is not empty, then let me take an example of this particular list. So what is shown here? There is one list. So I want to delete the last node because deletion at the end. This node I want to delete. That is 11 is what I want to delete. Now, what changes do we have to make? When I delete this node, Previous of this node you don't have to bother. But this next of 30 should now become null. Correct? Next of 30 should become null. That is because it is not pointing to 11 anymore. 11 doesn't exist at all. To do that, we should be able to move up to this location. We have to move up to the last node to delete this last node. So that is the reason I have taken a pointer called as current. What have we done first? Current is equal to head. So I have initialized current is equal to head. So this is current. Now I have to go up to the last node because I want to delete the last node. So how do I check that? If while current of next is not equal to null. So if current of next, this is my current. Current of next is not null because it is pointing to 23. So condition is satisfied. So current is equal to current of next. So this will become the current. Okay, next. Again I will go back to the while loop. While current of next is not equal to null. Current of next is 30. Okay, so it is not null. So current is equal to current of next. This will become current now. This is not current anymore. 30 will become the current. Again I will go back to the while loop. While current of next is not equal to null. Again. So this will now become the current. Again I will go back. While current of next is not equal to null. Current of next is null now. So this condition is not satisfied. So I will come out of the while loop. What I want to delete? I have to delete 11. So I can always, how do I display what I want to delete? Current of data. So 11 is displayed. We can write that CO deleted element is current of data. That is 11. Okay. Next, what changes you have to make? I said this should point to null. Is it not? Now this should point to null. How do we write that? Current of previous of next. You can do this kind of accessing because it is a double linked list. Current of previous. Which is current? This is our current. Current of previous is what? 30. Correct? Current of previous is, we know that it is pointing to 30. Previous of next. 30 of next. 30 of next of 30. That is nothing but your null. This one. So current of previous of next is equal to null. So current of previous is 30. Next of 30 is going to be set to null. Next. Current of previous is equal to null. So current of previous. Current of previous is what? This one. That also is set to null. So these are the two links that you will have to take care when you are trying to delete or delete at the end. Next you can write, if you are trying to, you can also write delete current. Why we are writing this? After this you can write that. That is because, as I told you, we said delete yes when we deleted at the beginning. We took a pointer yes. Now we are doing current because this node, we are deleting this node. So whatever memory is allocated to that, we are going to reallocate or rather deallocate that memory using current. Like it is similar to our free function. So all of us know what is free, is it not? We deallocate the memory that is allocated. Similarly, instead of free, we can make use of delete current. So current of previous of next, that should be null. Current of previous also you have to set it to null. Okay. So these are the two links that you have to change when you are trying to delete at the end. So next we will see how to delete a specific node. Okay, we saw deletion at the beginning, deletion at the end. So next we will see how we can delete a specific node. So if you are here observing here, we have taken int item. So the what is the item that you want to delete? That means which node you want to delete. That you have to accept from the main function from the user and then call this function from the main function by passing this as a parameter. Okay. Now I have taken one pointer called current. I am initializing current to head. Let me take this example. So I am taking this as my current. Head is pointing to 23. So I have initialized current to head. So current is currently pointing at 23. Now, while current of next is not equal to, I have to, let us say I want to delete 51. Item is 51. Let us assume. What is the item that I have passed? It is 51. Okay. Now, here current of next is not equal to null and current of data is not equal to item. I am going to traverse node by node. So current of next, is it null? No. Item current of data is what? 23. 23 is it equal to 51? No. So both the conditions are satisfied. So I will come into the while loop. Current is equal to current of next. So now current will come here. Next, again I go back. While current of next is not equal to null, current of next is not null. Current of data is not equal to item. Current of data is 35. 35 is not equal to 51. So it will again say, we will come here, current is equal to current of next. So current, this will become my new current now. Now, current of next is not equal to null. This condition is satisfied. But current of data is not equal to item. This condition is not satisfied because current of data is what? 51 is equal to 51. So I will come out of the loop. Okay. So when I come out of the loop, I will again come to this if statement. If current of next is equal to null, it is not equal to null. So it will not get into this, it will come here. See out current of data. What is current of data? 51. So I will display deleted item is 51. Next, when I delete this, what should happen? You have to change the next link of 35. This must now point to where? This link should now point here. And this should point here. Correct? Previous of 10 should point to 35. Next of 35 should point to 10. Correct? So one statement is enough to do that. Current of previous of next. What is current? 51 is my current. Current of previous is what? 35. Okay, current of previous. Of next, 35. Next of 35 is what? That should go to current of next. What is current of next? Current of next is 10. So that will point there. Next, I think one more line we should write. Current of next of previous. Current of next of previous. Current of next is what? 10. 10 of previous is should come to this one. So one more line probably I will have to add. So that will be current of next of previous. That will be equal to, see, current of, I said two links you have to change. This is current of previous of next. That should go to current of next. This is my current. Current of previous is what? 35. 35 of next should go to current of next. Current of next is pointing where? 10. So this should go to 10. Next, current of next of previous. This link previous of 10. That should come where? It should come to 35. Is it not? So current of next. Current of next is what? 10. 10 of previous. Current of next of previous. Current of next is 10. 10 of previous of 10 is what? Previous of 10. That should come to where? Current of previous. It should come here. Is it not? Is equal to current of previous. That is all you try to. And then these are the two changes that you have to make, and then you have to write delete current. Because this node is deleted, we deallocate the memory assigned to that particular node. Are you getting me? So we have displayed which element we want to delete, that is 51 is what I want to delete. If I delete 51, there are two changes I have to make. Next link of 35 should now point to 10. Previous of 10 should now point to 35. Correct? These are the only two changes that we have to make. So that is what I have written. Current of previous of next. You can write these kind of accessing statements because you are using a double linked list. Current of previous of next. This is my current. Using this node alone, I can access this also, that also, because I can use previous and next two links are there, is it not? So current of previous is 35. 35 of next. Next of 35. Next of 35 is what? Should be current of next. Should be 10. 10 is nothing but current of. That is how we have tried to write. So this finishes your session on double linked list. So double linked list, we have seen insertion at the beginning, insertion at the end, insertion at a specific point, display, deletion at the beginning, deletion at the end, deletion at the after a specific row. So this much we have seen with respect to double linked list. Okay, in your lab program you have a program to simulate stack and queue using double linked list. So stack means you know what stack is, insertion and deletion both at the beginning. So if you write insert at beginning and deletion at beginning, that is of double linked list what we have seen now, that is nothing but stack. Similarly, queue is insertion at the beginning, insertion at the end, deletion at the beginning. So all those functions we have already seen. So those four functions will form your stack as well as queue. So you can try that program in the lab. So this completes our session on double linked list. I see you all in the next session. Thank you.